It is Thursday, April 2nd, 2020, the fourth day of the week. We're going to talk about roots and zeros again in part 2 today. So the first thing we want to talk about is what we've talked about earlier this week and what the roots are and how many there are. So if we look at this first example, if we wanted to know how many roots there are, we would look at what? We would look at the degree. So what is the highest degree? The highest degree of an exponent is 4. So how many are there? There are 4. That was a really nice 4. There are 4 roots. So we have 4 roots. What are those 4 roots? Well, we can factor this down a little bit because both terms, the first term and the second term, both have something in common. They both have an x squared in common. So I can take an x squared out of x to the fourth leaves x squared plus 49. If I take the x squared away by dividing, it's just going to be plus 49 equals to 0. Okay, so now that I have 2 factors, I can set each of those equal to 0 and solve for my zeros. So I can say that x squared equals 0 and x squared plus 49 equals 0. Okay, so we know from yesterday that we can break x squared down into technically x times x equals 0. So x equals 0 and x equals 0. Yes, this is the same thing, but this means that x equals 0 has a multiplicity, remember, from yesterday. Multiplicity of 2. So that counts as 2 roots, even though it's the same number. Okay, so this other equation should also have 2 roots. That way we have 2 here, 2 there. That would be 4. Okay, 2 plus 2 equals 4. Quick math. Okay, so we're going to move this 49 over to the other side. So x squared equals negative 49. Square root both sides. Okay, if we're going to square root a negative, we want to write plus or minus. Okay, and the square root of x squared is just going to be x. So x equals plus or minus. We know that since this is a negative 49, we can take out an I. And the square root of 49 is 7. So my other set of roots is where x is equal to plus or minus 7i. Okay, so we have 2 roots here because we have plus or minus 7i. That also gives me 2 roots. So that would give me my total of 4 roots. So we know how many roots there are. We know what the roots are, and we know that x equals 0 has a multiplicity of 2. Okay, the next thing we want to do is use Descartes' rule of signs, and that's going to let us make better guesses of exactly what those zeros are. So we'll be able to know if they're going to be positive real zeros or negative real zeros. We're going to know better what they could be without working anything out, just by looking at the sign changes. So what we can do is notice that the amount of positive real zeros in a function will be the number of times the signs change, or less than that number by an even number. That last part's kind of tricky, but you'll see in a minute whenever we do this example what that actually means. So, pretty similarly, the negative real zeros, the amount of negative real zeros from this function is going to be the number of times the sign change when we're looking at f of negative x. So in positive real zeros, we're looking at the regular f of x. We're evaluating the function at x. In the negative real zeros, we're evaluating the function at negative x. And then this also can be less than this by an even number. Okay, so if we wanted to look for the positive real zeros, we would use f of x. And we're going to look at how many times the signs change. So from here to there, do our signs change? Our signs in front of our coefficient. So we have a coefficient there and a coefficient here. Do the signs change? They do, because it goes from a positive 1x to the fifth to a negative 2x. So I'm going to write, yes, they change. Okay, what about from this term to that term? We have a negative 2x to the fourth and to a negative x to the third. So no, they don't change there. All right, so from negative 1x to the third to positive 6x to the second, we change signs. From positive 6x squared to negative 5x, we also change the signs. And from negative 5x to positive 10, we changed our signs. So we went from a negative to a positive there. So we changed our signs 4 times. So that means that our number of positive real zeros can be positive real zeros. Zeros can be 4. There's a little piece after that, 4 or less than this number by an even number. So that means that it can be 4, 2. So basically we're just going to keep going lower to the next even number. So 4, 2, or 0. So that means that if we were to find these zeros, if we were to find all of these zeros by breaking all of this down, maybe by factoring, maybe by grouping, whatever we're going to do, if we were to group these and break these down, we would see that we would have some positive real zeros, and we could have 4 of them, 2 of them, or none of them. Okay, so let's look at the negative real zeros, see how many we have, or see if we can classify them just a little bit, just by looking at the sign changes. So remember, we're going to look at that whenever we have f of negative x. Okay, so f of negative x means that I need to do some things with this function. This isn't correct yet. We need to write f of negative x. What if I had negative x replaced for this to the 5th power? Would it be negative or positive? Assuming, let's do a little side work here. What I really mean here is, if we plugged in a negative number for x and x to the 5th, if we plugged in, let's say, just negative, we can do negative 1. If we did negative 1 to the 5th, since we're raising it to an odd power, it's going to stay negative. So this is still negative 1. Okay, so if we throw negative x into bx right here, we know that it's still going to be negative x to the 5th. Okay, so I don't really need these parentheses. Negative x to the 5th is what this is going to be. Since this is a even exponent, x to the 4th, and we're throwing a negative x in there, let's look at this. If we had x to the 4th, and we were going to substitute that with negative 1 to the 4th, that would be equal to what? It would be equal to a positive 1. So essentially what that means is it's going to change our sign. Okay? So if this changes our sign, then we would say that negative 2, negative x to the 4th, which is going to be, if we would evaluate this, we know that this is going to be a positive number, right? X to the fourth, we just said is going to be a positive number. So I can essentially take this off. So since it changed our sign up here from a negative to a positive, x to the fourth is still positive. So negative 2 times x to the fourth is still going to be negative 2x to the fourth. Okay? So you will notice that whenever we have f of negative x, if the exponent is odd, we're going to flip the sign. Okay? If the exponent is even, we're going to keep the sign the same. Okay? So if the exponent is odd, we're going to flip it. And if the exponent is even, then we're going to keep it exactly the same as what it was before. All right, so let's just flip these really quick. So this exponent is odd, so it's going to turn even. This exponent is odd, so the sign is going to turn positive, is what I meant to say. Then this is x squared, so x squared is even, so we're going to keep our signs the same. Negative 5x to the first, that's an odd exponent, so I'm going to flip my sign. And then this is to the 0th power, so we're going to keep it. Okay, so now how many times are we changing our signs? Did we change our signs there? Nope. Here? Yes. Here? Nope. Positive to a positive. Here? Nope. Positive to a positive. And here? Nope. Positive to a positive. So we only changed our signs once. So the amount of negative real zeros is 1. So there is one negative real zero. Just by looking at this Descartes' rule of signs, we can say that there is one negative real zero. Okay, so we can classify a little bit just by looking at the sign changes. All right, so for your exit ticket today, I want you to determine the number of zeros, so the degree, highest degree, and then I want you to determine the number of positive real zeros and negative real zeros. All right, today is the last day of the week. You need to work on Alex tomorrow, and I will catch you guys next week. Have a good weekend, and see you soon.